My name is Engineer Holiday. I'll be discussing types of machine in this class, and I will start with lever. Although there are majorly six types of machine that is widely used, and these are the lever. That is number one. Number two, we have the inclined plane. Inclined plane. Number three, we have the pulley system. The pulley system. Number four, we have a wedge. Number five, we have wheel and axle. While number six, we have the word number one, lever, two, inclined plane, three, pulley, four, wedge, five, wheel and axle, and six, we have the screw jack. Those are the six type of machine that we have. So I'll pick it accordingly and begin to explain them one after the other. Although in this video, I will explain the first one, which is what? Lever, so that we can have a proper breakdown of each of the machine. Now, when we talk about lever is a what? The simplest machine. That means if you ask you among this machine now, which of them is what? Is the simplest machine? Lever. How? Now I will show you the arrangement why is it simple. And it uses what? Uses smaller what? Effort to overcome a large resistance. That means load. That's what I mean. A large resistance. Now that means it uses smaller effort to overcome a large resistance and overcome a large load. That is to say, is a very good machine. Now let's see the arrangement, the setup of this machine. The setup is very simple, like this. Is setup. Now it has a pivot. It has a pivot. The setup of the machine has a pivot. Then it has an effort on one side. Effort that is where the application of what? Force will be applied in order to lift a what? A very large load. Now most of the times the setup always have this one as a fulcrum, or what we call the pivot. This one is the load. So that means when you see a lever, it must have these three characteristics, and there must be distance from the effort to the pivot, to the fulcrum or pivot, and there must be a distance from what? From the load to the fulcrum. Now most of the times in this machine, A is always greater than B in order to achieve this purpose. And number two is that the load is always more greater than the effort. Now this machine operates on the principles of moment. It operates on the principle of moment. It operates on the principles of moment. So that is to say, lever actually operates on the principle of moment. What is moment about this point? The pivot. It's simply what the load times distance moved by load, which is B, is equals to what? Effort times distance moved by what? Effort, which is A. Don't forget, principle of moment say the word the force times the perpendicular distance. Don't forget the force times perpendicular distance. The same thing with this one, the force times perpendicular distance. So this is simply what it's saying. So by principle of moment, ideally, you can say load over, let me bring this one here, over effort equals to what? A, which is what? Will remain here. That means divide both sides by what? Effort and B. You know, I want to remove this one from here. I want to remove this one from here. So if you divide, what I'm saying now is that if you divide by what? B times what? Times load times effort. I needed to remove this one, I needed to remove this one here. So divide both sides by what? Effort times B. At the end of the day, you are going to have this one remove this, then this one cancel this. So I want to be left with load over what? Effort is equals to what? A over B. What is A? A is distance of effort all over distance of load. So these are the what? So that means ideally what we are saying is that the mechanical advantage equal to velocity ratio, you know, was ideally. But most of the times in this machine, we always have an efficiency less than 100%, because in trying to lift the load, there are several resistance. When you apply effort here to lift this load, is the load will go against a resistance, and that resistance is friction. And once there's a friction that will occur there, that is, there will be decrease in what? In the efficiency. It will not be what? Equal to 100%, rather it will be less than what? 100%. Now, having understand this one, let us talk about types of lever, which is the last thing I will talk about. Type of what? The types of lever. What are the types that we have? Now we have the first class. We have the first class. We have the second class of lever, and we have the third class. The third class of lever. So that means that all these levers are explained based on the arrangement or the position of the effort, fulcrum, and pin and the load. So that means we classify lever based on the position of the effort, the pivot, and the load. So the first class is simply saying that when the fulcrum is between the effort and the load, we said it is first class. So that means this is the shortcut I will give you for that definition. So that means that we have this first class, second class, and this third class. What does that mean? Now flare, everybody say flare. Now that flare means that the fulcrum, when it's between the load and the effort, it is first class. The fulcrum, when it's between the load and the effort, or effort and load, is first class. Number two, when second class now is when the load is between the effort and the fulcrum, we say it's second class. That means when the load is between the effort and the fulcrum, or fulcrum and the effort, they call it second class. Then the last one, which is what? Third class, is what? When the effort is between the load and the fulcrum. When the effort is between the what? The load and the fulcrum, we call it what? The third class. Now, for you to remember this class, I can give you the shortcut called the Skimply Clappings. The Skimply Clappings. Yes, one calves. Now, what is this shortcut all about? The first one is for first class. Second is what? For examples on second class. And the third one is what? For third class. First class, second class, and third class. Skimply clappings, one calf. Now, what does that mean? Let me explain what the meaning of that shortcut. Say it after me. Skimply clappings, one calf. Now, the C here is what we call the scissors or the seesaw. The scissors or seesaw is an example of what? That from this statement. Then the PLI is what we call the plier. The plier is that one is the PLI. Then this one is what? CRO is what we call the crowbar. The crowbar. Now, what about the what? This one, the CLA. The CLA is what we call the claw hammer. The claw hammer. The CLA is claw hammer. Why this one, the PIS is what we call the pincer. PINS is what we call pincer. All these ones are for example for first class lever. First class lever. So now, these are examples just skimply clappings. Skimply clappings is what we're able to remember, because in the examination case, they will tell you which of these following is not a first class lever. So they will ask like that. Second one is what? The examples of what? This one is example of what? Second class lever is what we are going to use the word one. I mean, in terms of the past tense of way. Now, this is what? Wheelbarrow. Now, then O is what? Opener. Then N is what we call the nutcracker. So this one now will enable, this shortcut will just enable you to remember all the examples, because sometimes in the examination they can tell you to list about 3 examples. If it's theoretical exam like WAEC, they list 3 examples of what? Of first class lever or second class lever. Then third class lever is what? Calves. Now calves examples, let me say example of what? Third class lever, which is the last thing there. Then I will use what? The first K is what? Knife, or what we call the table knife. Then the A there is what we call the arm of human, the human arm. Then the F there is what we call the fishing rod. F there is called the fishing rod. Why the X there is what we call the sugar tongue. So these are the examples of what? Of the third class lever. The examples of third class. This is example of first class, example of second class, and this is what? Examples of what? Of third class lever. So just repeat after me. Skimply clappings, one calf. Skimply clappings, one calf. Skimply clappings, one calf. So examples of first class lever, second class lever, and third class lever. Then this one is talking about how to define the what they call it first class. Whenever the fulcrum between the load and the effort first class, load between effort and fulcrum second class, effort between the load and the fulcrum. So whenever they ask you any question, you can always tell them the first class lever is a lever in which the fulcrum is between the effort and the load, while second class lever is a lever in which what? The load is between the effort and the fulcrum, and the third class lever is a lever in which the effort is between the what? The fulcrum and the load. Thank you very much. My name is Engineer Halide. God bless you.